Open science infrastructures are recognized as a pillar of open science. The UNESCO recommendation on open science recognizes open science infrastructures as key to the operationalization and sustainability of open science. Open science infrastructures refer to shared research infrastructures either in virtual or physical form that are needed to support open science and serve the needs of different communities. Open science infrastructures may include, but not limited to the following: major scientific equipment or sets of instruments, knowledge-based resources such as collections, journals and open access publication platforms, repositories, archives and scientific data, research information systems, open bibliometrics and scientometric systems for assessing and analyzing scientific domains, open computational and data manipulation service infrastructures that enable collaborative and multidisciplinary data analysis, and digital infrastructures. Typically, open science infrastructures are the result of community-building efforts, which are crucial for their long-term sustainability and therefore should be not-for-profit and guarantee permanent and unrestricted access to the open science citizen to the greatest extent possible. To successfully implement the open science infrastructures, there are a number of challenges that require proper actions from the community or open science stakeholders. First, lack of interaction model. Open science infrastructures require completely new models of interaction between commercial companies, publishers, technology providers, data aggregators, nonprofit organizations, and the research community. Developing open infrastructure for the creation, dissemination, and assessment of scholarly outputs will require these parties with disparate incentives to work together. Without viable and sustainable interaction model, it is impossible to realize the open science infrastructures for the benefits of open science citizen. Second, demand for robust and scalable data storage and sharing. With the exponential growth of data, researchers generate and collect massive amounts of data. The data growth is also further intensified by the growing number of researchers and users' participation as open science community. Hence, it is inevitable to ensure that open science infrastructures are able to address the demand for robust and scalable data storage and data sharing. Third, interoperability, protocol and standards. Different scientific communities often use different data formats, software, and platforms. To promote open science, there needs to be a way to ensure that the open science infrastructures can interoperate seamlessly. Further to this, open science relies on the development and adoption of standardized protocols and formats. Developing and implementing these standards can be a significant technological challenge. Fourth, access to compute resources. Many scientific research projects require significant computational resources, such as high-performance computing clusters or cloud-based computing environments. Hence, it is vital to ensure these resources are always available and accessible to the researchers. This demands substantial resource allocation to meet the user's needs. Fifth, long-term preservation. Preserving data for the long term is a critical aspect of open science, but it can be challenging to ensure that data remains accessible and usable over time. This requires developing sustainable data preservation strategies and infrastructure that can withstand technological and organizational changes over time. Sixth, security. Open science requires that data be openly accessible, but at the same time, researchers must ensure that sensitive information is protected. Therefore, open science infrastructures need to be equipped with sufficient security measures to prevent any security incidents. In order to bolster the open science infrastructure's implementation for all, UNESCO has recommended the following infrastructure-related provisions. Invest in open science infrastructures and services by creating systematic and long-term strategic investment in science, technology and innovation, with an emphasis on investment in technical and digital infrastructures and related services, including their long-term maintenance, and promoting non-commercial open science infrastructures and ensuring adequate investment in open science infrastructures. Promote international and multi-stakeholder cooperation by promoting and stimulating cross-border multi-stakeholder collaboration on open science, including by development and use of shared open science infrastructures, and promoting cooperation among countries in capacity building for open science, including infrastructure development. Use open infrastructures when monitoring the implementation of open science by keeping the monitoring of open science within public oversight, including the scientific community, and whenever possible supported by open non-proprietary and transparent infrastructures. Develop an enabling policy environment for open science by designing, implementing and monitoring funding and investment policies and strategies for science that address the costs associated with the development and adoption of open science infrastructures and services. Bolster innovative approaches for open science at different stages of the scientific process by promoting the development of shared infrastructures for the collection, preservation and user-friendly access to open source software and source code.